All right, last but not least, we're going to move on to the vector stuff. So on number 6, we're looking at quadrilateral ABCD, and we're told it's a parallelogram, which is something that we use with vectors quite a lot. And we want to find the following. So first of all, I'm going to look at the questions, just because I want an idea of what kind of answers I need to give. A and B just look like vectors being added together, and if you add a vector plus a vector, you will get a vector as an answer. So here I'm expecting a vector, and here I'm expecting a vector. The difference with letter C is there are these absolute value signs on the outside. And if you should remember what we talked about in class, that absolute value sign really means magnitude. And so this actually will have a number as an answer. It will be the length of the resultant vector. Okay, now that we know that, let's get started. For A, we want to add AB plus CD. So A goes from here to B. C starts from here back to D. And we want to add these two vectors together. Now I know it's a little bit hard to understand since the two of them don't connect and people don't understand. But we can move vectors around in space anywhere that we want them to. I can take this vector and I can move it around anywhere. I can even put it right back here starting at point B. So imagine if we start at point A, move towards point B, end up here, and now I go from B all the way back. I have begun and ended my journey at the same point, which is point A. And if that occurs, according to vectors, you have gone nowhere. You have gone the 0 vector. All right, next one. And I'm just going to get rid of these right over here. I want to take vector AB plus vector AD. So let me use vector AD. Vector AD going from here up to here. Once again, we're allowed to move vectors anywhere we want. Now, why would I even need to do that? A lot of people would just look at this problem and say the answer is BD. It's not BD because we're not allowed to add vectors when they're tail to tail, like these vectors are right here. We need to add vectors when they're head to tail. So instead, I'm going to pick up this vector and I'm going to move it over here because BC is exactly the same. And now you can see that we begin our journey all the way down here at A and we end our journey up here at C. And so the resultant vector, or AB plus BC, becomes this vector, which is AC. And vector AC is our answer. All right, moving on, last but not least, our last problem tells us to take BC and CD and add them together. And then, only then afterwards, are we going to take the magnitude of our answer. A lot of people would just say that's 9 plus 15 because BC is 9 and CD is 15 and 9 plus 15 is just 24. That is the answer to this question. If I said what's the magnitude of BC plus the magnitude of CD, you could definitely tell me the answer is 9 plus 15, which is 24. But instead, C asks us to add the vectors together and then find the magnitude of that answer. So let's first add the vectors together. If I go from B to C, and then I go from C to D, I have begun my journey at B, I have ended my journey at D, and the answer to the inside of that problem is BD, the vector. Ooh, and I wrote BB, and I meant to write BD. Okay, I still can't forget about the magnitude symbols because those are still there. So this question is really asking me, how long is vector BD? We want that. All right, we know that this side is 9, we know that this side is 15, and we know that this angle up here is 40 degrees because this angle down here is 40 degrees. And opposite angles in a parallelogram are congruent. If we have two sides and we know the angle opposite, we try to look at our 3 ways of solving that we've done. First way is if it's a right triangle, but this is not. Second way is law of sines, and we don't have an angle side combo. So our last resort is the law of cosines. Law of cosines. I'm going to start out with my angle. I love to start out with my angle, which reminds me to put the side opposite my angle all the way over here on the other side of the equal sign. The other 2 sides, the 9 and the 15, they go in. I square them both. I subtract 2 times their product. And I end up with a statement where I have all the numbers on the right-hand side and only x on the left. This is the easy law of cosines. It's the one where I get to type it all in. 9 squared plus 15 squared minus 2 times 9 times 15 cosine of 40. Hit enter, and I end up that x squared equals 168, etc. That's x squared, and I actually want x, which means I need to take the square root of that answer, and I end up with 9.958. That is the value of vector BD, 9.958. Numbers 7 and 8 are our adding methods. I'm adding using head to tail and using the parallelogram method. So we had done this in class. Head to tail method was always talking about taking one vector, making the tail of this vector touch the head of the other vector. And our answer, our resultant vector, started at the first tail. Oop, I moved the wrong thing there. There you go. Started at the first tail, ended at the last head, and went in this direction. So I'm going to do the same thing. It doesn't matter which vector we start with. Addition is commutative, so it's up to you which way you want to do it. I'm going to actually do here you go. I'll do the opposite way around this time. I'm going to travel down this vector, and then I'm going to connect to this vector right here. So I started, I finished, and this is my resultant vector right there. All right. Number 8 talks about adding using the parallelogram method. So the parallelogram method is all about creating a parallelogram. It's really useful when the two tails meet together like we have right here. So we basically take this vector and copy it, and then this vector and copy it, and you create a parallelogram. Our path for our resultant vector will always start where the two tails meet right here in the beginning, and it will always end where the two heads meet over here, and our resultant vector will look like this. We can do that multiple times. And I'm going to do this one right here. Oop, wrong one. There you go. So I make my parallelogram, and my answer, my resultant vector, will start from the two tails, and it will end with the two heads, and it will go like this. 9 and 10 are our word problems. And vector word problems are pretty straightforward. The ones that we're going to look at are all about right angles. So I personally would love it if you could follow the way that I do it. I think it eliminates a lot of errors. So when I do this, I start with the first direction, I draw it, and from the end of that direction, I start drawing the next direction. So here I have an airplane pilot. He's traveling 500 miles per hour south. So 500 miles per hour south. This is 500 miles per hour, and I'm putting the arrow in direction of south. And then he's going to travel 75 miles per hour due west. So from the end of the south, I'm going to go west 75 miles per hour. And we want to know, to continue flying south, what adjustment to his navigation does he make? Navigation really implying direction, and direction really being talking about an angle. So let's talk about where he's actually going. If he starts here, and this is the end of that second vector, this is the path that he's actually taking. This is his path. Now, if we were asked to find out how fast he's actually flying, we would want the length of that side. And since south and west make a right angle, we could use the Pythagorean theorem. Instead, though, we really are being asked, what angle, what direction is he taking right here? It's a right triangle. I'm asking for an angle, and so now we're going to use SOHCAHTOA. So I'm going to use my little node chart. My angle, that's what we really want to know. We have 75 and we have 500. 75 is opposite this angle. 500 is adjacent to this angle, and so we need to use tan. The tan of x equals 75 over 500. I want to free my angle sign. I want to free the x from the tan, which means I have to do this inverse tan of 75 over 500. I'm really doing it to both sides, but when I do it to this side, I just drop that tan. So second tan, 75 divided by 500, and we get x is 8.530 degrees. It's an angle, so it's degrees. That means he's flying 8.53 degrees off of his course, and he needs to adjust 8.53 degrees to get back on course. All right, next problem. A plane is flying due north, so apparently we really liked planes here. So I'm going to draw north, 250 miles per hour. And the wind is blowing to the east, 40 miles per hour. We want to draw the plane's actual path. So the actual path, if he's trying to head this way, he's trying to start here, the wind is blowing him over here, his actual path is this line. Part B, I want to find the speed and direction of the plane. Well, if this 250 miles per hour is a speed and 40 miles per hour is a speed, this side right here will be a speed as well. It's a right angle because north and east make a right angle. So 250 squared plus 40 squared equals x squared. I'm going to use the Pythagorean theorem for that. 250 squared plus 40 squared on my calculator. That tells me it's 64/100 is x squared. Take the square root of that answer, and that tells me that x is 253.179. Miles per hour, actually. Miles per hour. That's how fast he's going. The next part of that question says, what direction? So the direction is an angle, and I'm always, if I ask you an angle, I'm going to ask you the angle between the two tails. It's the one that makes the most sense to us. So between the two tails here, that's the direction we want to know. And once again, it's an angle, and we have all three sides if we want to use them. I'm going to use the sides that we were given. So my angle is x. I know 40 and I know 250. 40 is opposite angle x. 250 is adjacent. There's our friend the tan again, because it's opposite and adjacent. The tangent of x equals opposite over adjacent. We want to free the x from the tan, which means we have to use that second tan button again. 40 divided by 250. So I'm going to do second tan 40 divided by 250. And that gives me that x is 9.09 degrees, which means he's moving 9.09 degrees towards the east. All right, good luck studying, guys. Don't forget your calculators tomorrow.